This is the part 3 of DP series, and in this video, we are going to solve a very famous question, house robbery, asked in many interviews. So, without wasting any time, let's directly get into the video.
Okay, so we are on our screen right now. In this question, what we have to do, we have to basically, we are given each index represent a house and its value is the amount which the house contains. We have to get the maximum amount which we can rob. If we rob this first house, then we have to leave the adjacent house. We can't rob this adjacent house also, otherwise we will be caught. So in this, we have to return the maximum amount which we can rob in a night. So the first solution which might come to your mind is just directly sum the odd and even places and check which one is maximum. But what if there is a test case which is something like this: thousand, one, one, then again thousand, then one. In this case, we have to skip two places in between. So we can't just directly sum up the odd and even places and get the answer. So again, we have to explore all the possible cases where we have to check include the first house. Then we have to check by excluding the first house and including the second one. We have to check all the possible cases. So the first solution which comes to my mind again, as discussed in the last video, is recursion. With recursion, it's really easy to check all the possible cases. So let me quickly just type its recursive solution. So if I is greater than equal to nums.size, we can simply return 0, which we have iterated to all of the houses and we can't rob any house, so we are returning the value 0 here. And then we can check after including this house first. If we are including this house, then we have to skip the adjacent house. That's why I've done I plus 2 here, and and then add the amount of this house to this. And then we have to check the answer by excluding this house. If we are excluding, then we are not robbing this house, so we'll not add the amount of the current house, and then return the maximum include, max of include and exclude. Remember, you have to only think about one case during recursion. Just the recursion will handle it. It's a really simple trick if you have problem to understand recursion. And then finally, you can simply return this. Let's try to run it. The code is running successfully, but it will obviously give me a TLE if I try to submit it because its complexity is really bad. Time complexity is really bad. First of all, let me explain you this solution through a recursive tree. In this, what we are doing, we are including for one place and then calling the function again. Then we can include. This will cover all the include cases. Then exclude will start. And exclude, once we are excluding all, then include. This will cover all the possible patterns which are possible in this question. So we have covered all the possible solution, but there is one problem. We are calculating already calculated solution again. For example, when we reach this second last index, we know the maximum amount of money which we can drop in this array is 3. We have already calculated using recursion. You can check by drawing its recursive tree. It will be really great if you draw the recursive tree on your own, because that will give you much more clarity about this question and will help you solve further DB questions also easily. So then we are somehow visiting this 3 again and then again solving for this 3, which is really not efficient. So what we can do, we can just simply create an array of size nums.size and initialize every value with -1 so that we can easily differentiate. And then we can add a condition here: if dp of I is not equal to -1, then we can simply return dp of I, which means we have calculated the amount for that maximum amount for that index. So we don't need to calculate it again. We can simply return it. And then we can here store the maximum amount for that particular house and then pass the DP here. Now let's try to run it again. We haven't passed the DP here again. As you can see, this solution is running successfully. Let's try to submit it. And as you can see, it got submitted. We reduced the time complexity to just O of n, but it's now taking space complexity O of 2n because O of n is because DP array is of size O of n, as well as recursion stack also also takes space when we call it again and again. So it is also taking O of n space. So how can we optimize the space further? As discussed in the last video, we can solve it using tabulation method of DB. We can simply create a grid and start calculating answers from the opposite end to the first and then return that. I'll soon tell you why I have done +2 here. So don't worry about that. I have initialized everything with -1 because by default, when we reach the base case, we get value 0. If we'll put -1, then we'll get, obviously, when we'll plus things in DP, we'll get the wrong answer. So what we are doing in this question, in the recursive solution, we are going from 0th index to the last index and then calculating the answer from last index, because when we call DP, it will first reach again and again call include and reach the last index and calculate for that last index first. So we are calculating from last index. So in tabulation method, we can try calculating this amount from last index itself. So we can use the same solution as it is. So we have created a loop from I equal to n-1 to 0, and then we can simply copy paste this exact solution and simply and write here dp of I plus 2 and here dp of I plus 1 here, and then store the max here. And then after iterating from calculating things from last index, first we'll include, then we'll, if we are including, then we will also include the amount of next to the adjacent element which is next to the adjacent element. If we are excluding, then we'll simply include the amount of the last next element. And then for the current index, we are storing the maximum amount. So we are calculating the maximum amount at every index from last to first. And in first, we'll have the maximum amount which a robber can rob. So now let's try to run it. Uh, there was no n here. I have to write nums dot size. I should have declared a variable n for storing nums dot size. And I have done +2 here because with just nums dot size, we'll get the index 1 less than nums dot size, and we are accessing here 2 index ahead of nums dot size -1. That's why I have written +2 here. Now let's try to run it. And as you can see, it's running successfully. And as you can see, it got accepted. Now let's try to optimize this further. First of all, what we did, we optimized it using the BP array. We were not calculating the same answer again and again. Instead, we stored the answer for a particular index in the DP array so that we don't have to calculate answer for that index again. In this case, we were using O of 2n space and O of n time complexity because we were iterating each an element just once. Now, in solve tab, we are not using recursive stack space, so space complexity is just O of n, and also we are iterating each an element, so the time complexity is also O of n. Now, how can we reduce the space complexity to just O of 1? Yes, we can because we don't need an entire array at one time. We are just accessing the next to next element and the next element and the current element. So we can do this whole just with four variables of one constant space. Let me just quickly write the code and then I'll explain. Okay, so here TP of I plus 2 means next to next. So I'll write next to here. TP of I plus means next element. I'll write next here. And DP of I means current element. Now each time we have to update the next element to the current element because in the next iteration, the next element will be the previous current. So we are storing previous current in the next. And before the current changes, we are storing the current's value inside previous, and then finally we are returning current. So let's try to first run it. It's giving wrong answer because I have written next to current here, which should be previous. And as you see, it ran successfully. Let's try to submit it. Don't worry, I'll explain it once more. And as you see, reached 100%. Now, what did I did? We were accessing just, we don't need entire array at a time. We were just accessing the next to next element, the next element of from the current index and the current element. So we are calculating the current element with the help of next to next. And after calculating the current element, before the current element changes, we are storing previous to current element so that we can give it to next to next element. Now this might sound confusing. For example, this is the current element, 2 is the current element. So the next one will be 3. So before the iteration comes from 2 to 3 to 2, we are storing next element current is equal to current. So in the next iteration, when index will be on 2, next will have value 3. So in next, we are storing the next element. This must be clear by now. In next to next, how can we achieve this? How can we store next to next value? For storing next to next value, what we are doing before this current value changes. For example, we are on 3. Before this current value changes, we are storing the previous current, which was 1. Now the current value changed to any other max of include exclude, which I think will be 3 here. Then we are storing the current value 3. next, and then next to is previous. Next to is previous means it is 1 now. And now when we'll come to this 2 index, now when we'll come to this 2 index, the previous will be, next to will be 1, and next will be current. So this is how we are taking care of next and next to element and changing them on each iteration so that we don't have to use an entire array for storing all the elements. We don't need all the elements at the time. We just need the next one and next one. So I hope you understood this question and the solution of it. It was a really easy question. I will suggest you to make the recursive tree of this question on your own. Then only you will get a solid understanding of how can you solve DB questions easily. How is recursion working exactly? Also, after doing this question, to try this question house robot 2 as homework. It's really easy. It's just in this question, the houses are arranged in circular order, and remember, we cannot rob adjacent houses. So that was the hint for this question. It's exactly same as the previous question. Just 1 or 2 lines will be changed here. So do try it out as homework. So let me discuss its time and space complexity, which we have already discussed earlier. Let me discuss it formally. In recursive solution, we were using O of n square space. Then we memoized the solution using the DP array. With which we were traversing each element only once. If we have calculated the answer for a particular house, then we were simply returning it here. So the time complexity became O of n and space became O of 2n, which is O of n basically. Now in solve tab with DP array, the time complexity O of n and space O of n. But then we reduce the space complexity further to just O of 1, which is great. Most optimized solution which you can reach. So that was it for this video.
So that's it for this video. I hope you found this video helpful. If you did, don't forget to like, subscribe, and share it with your friends. Do comment down which type of videos do you want in the future. And don't forget to solve the homework question and make a recursive tree on your own. I'll see you guys in the next one.